Today's pre-cal lesson is about summation, notation, and series. Part A, let's talk about summation, which makes sense. It comes from the root word of sum. That's to sum a bunch of pieces of a sequence. So the sum of the first n terms, this is a fancy definition, is defined by, and then we have this symbol right here, which is like a sigma. That means the sum of I equals 1 to n. I is the index, that's where you start, and n is the stopping point. And of I sub 1, so that's of the sequence sub I, is A1 plus A2 plus A3 plus on and on and on, all the way to the nth term of the sequence. So I just find each term, add them up n times. Okay, that's how many I want. N is the index, so let's go ahead and write that. Where I is the index, n is the upper limit, and 1 is the lower limit. In this case, 1 is the lower limit because I have started that way. That number actually can change. All right, let's look at some examples of what this looks like in a problem. Example 1, the summation of I equals 1 to 5 of 3i. Okay, let's go ahead and find the first several terms. I'm starting with 1, so I'm going to do 3 times 1 plus, next term, 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Now that's 1, 2, 3, 4, 5 terms in the sequence. It's till I equals 5. So once I've solved that out, I'm going to get my answer. 3 times 1 is 3, plus 3 times 2 is 6, plus 3 times 3 is 9, plus 3 times 4 is 12, plus 3 times 5 is 15, and that makes 45. So the summation of I equals 1 to 5 of 3i is 45. If I look at another example, the summation of k equals 3, so k is just another lower limit, or index. 3 is the lower limit, and I want to go to 6 is my upper limit. That's a little 6 there. Of 1 plus k squared. I'm going to start at 3. I'm going to go till k equals 6. So I'm going to start with 1 plus 3 squared plus 1 plus 3 cubed plus 1 plus 3 to the 4th plus 1 plus 3 to the 5th plus 1 plus 3 to the 6th. And I stop because my k is now equal to 6. And I want to sum those terms. Oh, I don't know why I started with 2. I should have started with 3. I'm sorry, guys. Oh, because I read the problem wrong. Okay, I'm too far in to start this podcast over, guys. So I am just going to admit that I messed up there, and I'm going to start you over on the problem part. K is what I'm replacing. So I have 1 plus 3 squared plus 1 plus 4 squared. See the difference in what I was doing before? I was just using the wrong formula. Plus 1 plus 5 squared, plus 1 plus 6 squared. Again, I apologize about that. If I do 3 squared, I get 9, plus 1 is 10, plus 4 squared is 16, plus 1 is 17, plus 5 squared is 25, plus 1 is 26, plus 6 squared is 36, plus 1 is 37, and if I add that up, that's equal to 90. I'm going to say that again, just a few parts of that to make sure you got this. The k is starting at 3. So I replace k with 3, and I do 3, 4, 5, and stop at 6 because 6 is my upper limit. Once I work that out, I get 90 as my final solution. Let's do another example. Again, I apologize for that mistake. The summation of I equals 0 to 8. This time I'm starting at the 0 term and going all the way to 8 of 1 over I factorial. Remember, factorial from yesterday means n times n minus 1 times n minus 2 and on and on and on. So if I start this right here, my answer, I'm going to do 1 over 0 factorial, plus 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial, plus 1 over 4 factorial, 1 over 5 factorial, 1 over 6 factorial, 1 over 7 factorial, and 1 over 8 factorial. And I can stop at 8 because that is my final number. 1 over 0, remember 0 factorial is 1, so 1 over 1. 1 times itself is 1 over 1. 2 times 1 is 2. 3 times 2 is 6. 4 times 3 is 12. times 2 is 24. 5 times 4 is 20. Times 3 is 60. Times 2 is 120. Guys, I'm kind of doing these in my head. You could also do these in the calculator. 6 times 5 is 30. Times 4 is 120. Times 3 is 360. Times 2 is 720. Times 1 is 720. Plus 1 over 7 factorial is 50, 40. Plus 8 factorial is 1 over 40, 320. And then I would want to use my calculator to get that. When I sum that right there, I'm going to get 2.71828, and that will continue. And that number should seem familiar from a very long time ago. That number is approximately e, the exponential function. That should be familiar to you, and that should make sense now where e is coming from. This is the formula for e, that number that goes on and on and on. There are more properties on page 647 if you're interested in some more information about that. That's as far as I'm going to go for our purposes. Part B of what we're talking about is a series. The definition of a series is the sum of the first n terms of an infinite series of a finite series, or nth partial sum is the summation of I equals 1 to n of ai. And that's a series. Of an infinite sum, is the sum of all terms of an infinite sequence, which is the sum from I equals 1 to infinity of a sub I. So the difference in a finite is there is an ending point, and infinite, it goes on towards infinity. Let's look at an example. Example number 4 for today is the summation of I equals 1 to infinity, and of 3 over 10 10i to the I power. And I want you to find A, the third partial sum, and B, the sum, or the infinite sum. This is a series. Okay, part A, what I want to do, I'm going to do the summation from I equals 1, and I want the third, so I'm going to stop at 3, of 3 over 10 to the I power. So I'm going to do 3 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third. And when I figure out what that is, 3 over 10 is 0.3, 3 over 100 is 0.03, and 3 over 1,000 is 0.003, which equals 0.333. Part B. So that one's the easier of the two. Part B is how do I find the infinite sum? To do that, I'm gonna go through what I think will happen. If I do 3 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third. I did that in my partial up here and got 0.33. Let's just say I continue. And let's say I continue to work that out. I'm going to get 0.333333 repeating, and we know that to be the fraction 1/3. So the sum is 1/3. Your assignment for this one is number 3, and it's page 650. It's number 73 to 80 and 99 to 100. Good luck. Let me know if you have questions, and as always, sometimes this is hard at first when there aren't specific steps. You will get the hang of it if you don't come to tutorials, and I'll help you out.